Machine vision. The machine vision is defined as a technology to replace or complement manual inspections and measurements with digital cameras and image processing. This system can be described in 4 steps, or otherwise the steps in machine vision. The first step is imaging, in which we are taking an image of an object or the workpiece. And the second is the processing and analysis. And in this stage, we are analyze the image to obtain a result. We are analyzing or comparing the grabbed image with our data set using computers on softwares. And then we are arriving in a result. And then the third stage is, or third step is the communication. And here we are sending that result for the systems to control the process. And finally, the action. So that action is that is the fourth step, which is depending on the vision system's result. So normally the action may be in form of rejection or acceptance. So after comparing the image provided by the machine vision system, the software provides a communication of whether to accept or reject the component. The working of machine vision systems and the 4 steps of operations can be explained using this diagram. So the first step, the imaging. So we are capturing the images of the workpiece. Here the workpiece is a gear wheel produced, and that is actually moving in a conveyor. So while it is moving, the camera is capturing the image. So that is the first step, the imaging. And the lighting is provided for getting better images of that object. Then the processing and analysis is done on a computer, and the computer is connected to the network where it can be gather information from some other sources. So that analysis and processing is happening on this computer, and communication is sent to the pneumatic cylinder here. So the pneumatic cylinder is actually used as an action element in this case. So with the communication, if the product has got some defects, and when the computer is decided that this is not acceptable or rejectable, then what will happen if it is moving and it is arriving here? This pneumatic cylinder will push this component out of this conveyor. So that is the action. And if it is acceptable, then there will not be any action from this pneumatic cylinder, and it will be given or transmitted to other station for further working. The main components of machine vision system includes a CCD camera, then a lighting system, then computer and software for analysis, and then it is then a frame grabber. And the camera is further classified into different kinds. And the first theme, it is a vision sensors. So vision sensor is a specialized vision system that is configured to perform a specific task only. It is not like general camera. In this case, in vision sensors, that is actually made to capture some specific uh, task or specific features. So in this figure, we can see that it is a vision sensor, and here it is actually capturing the label only, and this label is actually compared with a predefined label, and it is comparing it is correct or not. Another type is smart cameras. So the smart cameras are camera with a built-in image analysis unit, and that allows the camera to operate standalone without a PC. So here in analysis and comparison, we don't need a PC. The camera itself can compare the image with the predefined uh, of, drawings. So in this example, you can see that this uh, camera is loaded with the built-in image analysis, so the lines are actually built in, and this is comparing with the components which are other the image captured by the camera, and if these are matching within the tolerance limits, we can accept, or otherwise this part will be rejected. While in PC based systems, that is the camera, another camera system, PC based systems, so here the camera has to capture the image and it has to be transferred to PC for processing and analysis. So in order to have a better image processing, we need a clearly visible image of the components, and that is done by a lighting system. So the lighting system enables the camera to capture very clearly visible images, and these lighting sources are classified as fluorescent tubes, halogen and xenon lamps, LED, laser, etc. Out of this, LED is most popular. Sometimes we use analog video signals for machine vision system to capture the images, and if we are using these analog signals, we need to grab some single frame from that analog video signal, and that is known as frame grabber, and the typical grabber circuit is shown in this picture. The image captured by the frame grabber is then analyzed using a computer, in a computer using a software, and these various processes are done on the image, and finally the software will either count or measure or identify the objects in the image, and as a final steps the software passes or fails the part according to the programmed criteria. The machine vision system is find applications in measurements of the components, or counting applications, then decoding of some codes, or locating of or identifying the location of some features. The measurement application is illustrated with this picture, in which the camera measures the multiple dimensions of a bottleneck, and you can see the bottleneck, and it is the image is processed and its measurements are shown here. This image shows the application of counting of holes in our aluminum flange. So here it is counting the holes, and while it is counting, it is actually provides the location of each and every holes, and it also gives the information of any missing holes, etc. Here it shows the other application of counting. Here it is identifying the presence or absence of a part. And in location, here the machine vision is used to uh, locate the position and orientation of holes. As in this picture, the example is a gasket which is used on an engine cylinder. In decoding, it is an identification application in which the vision system reads various codes and alphanumeric characteristics and decodes the codes to get the product features. Thanks for watching.